If we achieve controlled nuclear fusion, how far can a car go with 100 grams of hydrogen based on a 50-gram deuterium and 50-gram tritium mixture? 100 grams of fusion fuel can release 17 billion joules of energy if a car's fuel consumption is 8 liters per 100 kilometers. Converting controlled fusion energy to gasoline mileage, the final result is 6.2 million kilometers. That's the range of this fusion-powered car. Earth's circumference is about 40,000 kilometers. This car could circle Earth 155 times. The average distance from Earth to Moon is 384,000 kilometers. It could make 16 one-way trips, 8 round trips, with plenty to spare. And this is just 100 grams of fusion fuel. If we fill up the tank with a full tank of fusion fuel, traveling to the Sun 150 million kilometers away would be more than feasible. Of course, this is just theoretical calculation. Once controlled fusion is achieved, the energy release from 100 grams of fuel is indeed remarkable, but actually installing it in a car would be very difficult. Because nuclear fusion produces plasma at hundreds of millions of degrees, difficult to convert quickly into electricity or mechanical energy to power a car, and nuclear fusion is an antimatter after all. It can't achieve 100% energy efficiency, but even if efficiency is only 10% of the calculation, 6.2 million kilometers reduced to 620,000 kilometers could still circle Earth 15 times. The bigger problem is actually device miniaturization. Current tokamak devices weigh 23,000 tons. Even if miniaturized in the future, they'll likely still weigh dozens to hundreds of tons. What could actually fit in a car is Iron Man's miniature arc reactor, but that's cold fusion, which belongs to science fiction. What could realistically use controlled fusion reactors as power sources would be future flying aircraft carriers at minimum, or even spaceships and space cities, or human bases on the Moon and Mars. After all, the millions of tons of helium-3 on the Moon is the ideal nuclear fusion fuel. As for driving with 100 grams of fusion fuel, in the future, that would just be a toy. Ideally, if wireless power transmission losses could be reduced, or if fusion power generation costs reached a level where losses don't matter, then all future transportation would probably be electric and would never run out of power, because wireless power would be as common as air. All electrical devices would have unlimited range. Since controlled fusion was first proposed, over half a century has passed. Based on current progress, in about 30 years at most, tokamak devices will move from laboratories to power plants, becoming super devices that can actually generate grid power.